first of all, before we dive deep into the, let me say, open source models, we can first of all understand the broader context. Basically, who are the biggest players in artificial intelligence? Because for the best part, we simply know of the chat GPTs, whatever provider you basically consume the most artificial intelligence from. But we can start with the first group, which is maybe not known to like so many people. We'll start with the hyperscalers. When I talk about hyperscalers, what I mean is basically these big companies, Google, Meta, Amazon, Microsoft, that basically build these very big data centers to simply cater for the artificial intelligence, for people to basically deploy their models to their servers. So when we talk about hyperscalers, these companies basically have a very big capex. Like Microsoft, for the year, I believe 2025-2026, they do have a capex of $80 billion to be spent on artificial intelligence. This means them basically building very big data centers, them getting some very lucrative now energy contracts. That's basically what we call hyperscalers. And a company can both be now hyperscaler and a company that builds large language models. So after the hyperscalers, we now go to the foundation model companies. When we talk about foundation model companies, these are basically the companies that build the frontier models. When I talk about frontier models, first of all I mean the let me say Cloud Sonnet 3.7, because that's basically my best model. We can say Cloud Sonnet Thinking, from Anthropic. That's a foundation model company. We can say DeepSeek. DeepSeek is a foundation model company, via their most famous models, V3, R1, depending on the one that you make depending on the one that you consume the most. Then of course we do have the best from ChatGPT 01, which is a thinking model. Thinking models are basically the new trend in artificial intelligence. When a model is now able to basically prompt itself, so that it can solve much more complex problems. So like what happens for the best part, for the now previous years, when you sent a model a prompt, that particular model would simply take like a second or two, then now generate your feedback for you. But when we talk about thinking models, for a thinking model, basically what we mean is a model which, when you send in a prompt, that particular model will say, okay, let me think about this. Some people say it's not thinking, but we can still call it thinking models. So that particular model will start prompting itself. That particular model will start coming up with a plan for it to be able to simply solve that particular problem. And you might find a certain model basically thinks for something like 30 seconds, depending on the complexity of the problem. A model can think for something like even 1 minute, 2 minutes, just depending on the context. So for the foundation model companies, we now do have those particular set of companies. Then we come to the application layer companies. When we talk about application layer companies, once the foundation model companies have built their models, they do host their models with these now hyperscalers. Once those particular models have been now hosted, for the best part, you might find a company like ChatGPT, Anthropic. They do have their own platforms via which they sell their own models. So you can simply go cloud, you can go access their models, and you can basically consume their models from that particular platform. But when we talk about application layer companies, once a model has been built, a certain company will now build an application on top of that model, meaning that the functionality that they do offer, they now consume from these particular models via an API. I do hope that many people know what an API is. So they basically consume from these particular companies. They call their APIs. Then they simply build more functionality on top of like what they do, which is basically what Proxima is. We are an application layer company. We do innovate at certain levels, but we try to basically get the best model to our customers to make sure that they experience the best form of customer support. So once we've spoken about the application layer companies, when you look at these three sets of companies, we can say that the application layer companies maybe now do have the least budget, because for the now hyperscalers, their budget is very big when you consider factors like land, the chips themselves are very expensive, and that's why we have seen Nvidia's stock price basically shoot up so much. Now let's come to the building blocks. When we talk about the building blocks, we have spoken about the now different players, but now we can come to the building blocks of artificial intelligence. I think it makes sense to maybe speak first about talent. Talent is extremely important. Most of the innovation that has been there for the past 10-15 years has basically come from very talented people. Most of them are, of course, concentrated in the United States, which is basically the innovation capital of the world. So when we talk about talent, we must first of all understand the difference in talent that we do have in, let me say, Kenya, Africa, compared to the difference in talent that we do have in the Western world. So the best part, when we see the changes that have come into play, you will find that they mostly come from people who have now highly specialized in certain sectors, which are extremely important. You might find someone maybe working at Meta. This particular person may be specialized in a PhD in stochastic optimization. But when you come to Kenya, when you come to now Africa, we simply don't have that level of specialization yet, meaning that we simply can't contribute so much to the breaking changes, the things that push artificial intelligence to the next level. So I think that's a very big weakness, to be honest, because when we can't focus on specific sections, when certain people who are very smart can't focus on specific sections, to basically bring out the best in it, maybe it's via optimizing these particular models, maybe it's via the training functions, we might fail to basically contribute so much to the frontier. But I think we do have some very, very smart people in Kenya, Africa, whom, given the right tools, given the, let me say, capital, they can basically be able to contribute so much to the frontier. But the biggest question comes, is that a priority for Kenya or for now Africa? Then we go to the infrastructure, the compute, and the connectivity. Okay, now let us talk about infrastructure, compute, and connectivity, which is also extremely important. When we talk about infrastructure, it basically means the buildings, GPUs, the various computers. So in that particular aspect, first of all, you must know that in Kenya, we simply can't get the best chips from now Nvidia, which is the H100s. They are very, very pricey, but there are now export restrictions that have been put in place by the Trump administration, meaning that we can't get the best chips. But even with the costs, I simply think that we can't buy them. Some companies can buy them, but it's a very, very big capital investment. But there are very, very good chips, same to the ones that DeepSeek now have, which they basically now use to bring about their best models. So I think we can still get some chips to basically be able to train the level of artificial intelligence that we can. Then from there we can see what happens. Then of course the biggest elephant in the biggest elephant in the room. I don't know whether I'm the only person, but I think that in Kenya we do have a very, very big energy problem, based now on the cost, based on the now distribution, and though controversial, that particular Adani deal made sense in some way, but it's just that some people were too funny with the whole thing. Yeah, but I think we do have a very, very big energy problem. When you put things into perspective, in Kenya, we pay $0.26 kilowatt per hour. That is that is basically 28 shillings. When you go to our neighbors Uganda, they pay $0.06 kilowatt per hour, meaning that we simply can't compete with them fairly for things that now require so much energy. Then when you consider the whole scope of artificial intelligence, so much now energy is consumed basically. So for Kenya maybe to play an important role, this particular energy aspect must be looked in very, very deeply. Then you come to data availability. We can say that most of the world has been, let me say now digitized, but we can't say that most of our now African values have been, let me say now digitized in a way that we can simply train models that basically bear our values. You can't find a model that has a very good perspective of the people of maybe Nigeria from Kenya. So we must basically focus on very good digitization of our content, our culture, our past. Because when we fail to do that, we fail to build models that basically mirror our own culture. Now we come to the people whom can bring about some very significant change. First of all is government. Government policy goes a very long way to making artificial intelligence basically much more simpler. They can come up with policies that make doing business much more simpler. They can come up with now policy investment that make the cost of now energy go down drastically. They can come up with certain programs that may be challenging for people specializing in this particular aspect, maybe doing some few scholarships. So government can play a very big role, but I don't think that's the number one thing in their minds. Then you come to academic institutions, which I do believe can play a very important role based on what they offer. So many universities in Kenya are basically now starting to embrace artificial intelligence as a course. But the issue is there are very few people whom can teach it. Because we do lack that particular expertise. Then the third one is tech hubs. I think there are several tech hubs in Kenya which are playing a very important role. But we must agree that they can play an even bigger role. Because they do have the potential to basically bring about so much change. Then of course we come to open source now initiative, which can play a very important role. Let's now come to open source models. We have understood the whole concept of the foundation model companies, application layer companies, hyperscalers, the building blocks, plus the different people whom can play an important role. But now we can talk about open source models. Before we talk about open source models, it makes more sense for us to basically understand what an open source model is. When a company does an open source model, what they basically do, they go through the process of basically training a model, getting the data, doing the code, paying for a server, and basically now training that particular model. When the model is satisfactory, they can now basically say, okay, like we have done this particular model. Then they can basically bring out something that we call a white paper, which is basically a very good documentation that will now simply have the steps that they followed, the now training methods plus some more technical things. Then they can basically now do the code. They can say, okay, like here is the link to the code. Then they can do the weights. When we talk about weights, basically we simply mean whatever that particular model has learned. So you can simply load those particular weights to be able to consume that particular model. Depending on the now license that they do have that particular open source model, you can or not basically now use that particular model for commercial purposes. And it is also extremely important to also understand the different companies that basically come out with the different open source models. First of all, we do have Meta. Meta is maybe the biggest player in open source models via their Llama set of models. Then we do have Microsoft. Microsoft have some very good small large language models. There are 5 class of models. Then we do have, of course, DeepSeek. DeepSeek is, I can say, the darling of so many African people. So you can say DeepSeek via their V3 model, plus their best thinking model R1. So we do have these different sets of companies that basically do different open source models. So in my own opinion, I think the main aim of open source models is to basically democratize artificial intelligence. Because when a company comes out with an open source model, this basically means that someone in Kenya, someone in South Africa can basically get that particular model, go to a cloud provider, Google, Microsoft, AWS. They can simply deploy that particular model, and when a model is small enough or someone has enough juice, by juice I mean compute power, they can simply deploy that particular model locally. Myself, I typically deploy in my own computer, in my own Mac. I can say models that do have about 2 billion parameters, which I'm not able to basically consume freely. Maybe do some very now large tasks that might cost me so much money when I go to something like ChatGPT. So those are basically open source models. Then we now come to are open source models cost effective? I can say yes and no at the same time. When we talk about cost effective, you can now look at it from this particular perspective. DeepSeek, when they trained their best model, R1, their final run of training that particular model was $6 million, and that sent so much shockwaves, because that was a very cheap price to train such a powerful model. When you consider companies like now OpenAI, they spend millions on top of millions simply training these particular models. And when DeepSeek came out with a very good model, that had cost just $6 million, that was a very big shock to so many people. But when you look at the same $6 million, I can safely say that so many Kenyan companies, so many African governments simply can't spare $6 to $10 million to train a large language model. So we can say that they are very cost effective simply because we now won't have to pay for that particular training. What we can simply do, we can get this particular model, then we can fine tune it based on our own now preference. I can say that they are cost effective in that particular angle. But why are they also not cost effective? When you do have so much scale, I think I saw somewhere that DeepSeek spends about $87,000 a day on a server to basically be able to host their models and serve their customers. That is still a very large price to pay, which I think is what might be some challenge. But when you consider it, they do have some smaller models which I believe you can make much more use of, which can be beneficial in the long run also. What we can say basically is that open source models are extremely important, simply because of the way they democratize artificial intelligence. Because it is extremely expensive to train a model, get the proper talent, and simply deploy that particular model with maximum efficiency. But I think that should not be the main strategy that we now do have. We should basically set up the fundamentals, get the proper talent, get the proper capital, get the proper legislation now moving forward, so that we can basically be able to build on top of these large language models which are basically now open source. And I think one thing that we should also focus on is basically the now innovation aspect. We should not just get an open source model and simply want to consume it. Yeah, we should get an open source model and say, okay, like, what is the innovation behind this particular open source model, and how can we best maximize on it? But I do believe that the future is bright for Kenyans, Africans. Thank you so much for watching this video. It was a pleasure being with you. Please share the video with your friends, family, and just someone who is a fan of artificial intelligence, and see you on the next one. Bye bye. Thank you.